What's up, everyone? It's Calc time with Miss Wesley. If you're following along, you can turn to page 12 of the volume packet, and we're going to start with number 4 at the top. I was just thinking that these problems can get pretty tricky, especially to visualize. So even with these practice ones that are on page 12 here, I just think it'll be good to talk through it together and see if we can get the pictures first and then get the integrals that'll help us find the volume. And you'll notice that all over this page and the last page, we're not spinning our shapes around the x or the y axis. Here it's the line x equals 2, y equals 1. What's the next one? Y equals 4. And y equals, well, y equals 0. This one would be an axis. And what is important about this line of revolution? If I know x equals 2 is going to be a vertical line, it kind of sets me up for the whole entire question. Now I know, why don't I put that line on both versions of this picture? And now I know here's your axis of revolution, x equals 2 here, and I'll put another one on this picture here. Because it's vertical, am I doing this whole problem in terms of y's or x's? And I'd say y's. Vertical axis of revolution, solve in terms of y. All right, let's see what this picture looks like. And a little joke to start. What did you call the guy with no face and no body and no nose? Nobody knows. Number 4 says first we have to graph y equals 2x squared. So let's do that here. We'll sketch it out. So 2 times 0 squared is 0. 2 times 1 squared is up at 2. And I say, just for the picture's sake, let's take this all the way to the line of revolution. So 2 times 2 squared is 2 times 4 is all the way up at 2, 3, 4, 5, 6, 7, 8. 8 is going to be an important number for this problem because we're integrating in terms of y's. So it looks like we're going to span 0 to 8 with the discs that we use. Go ahead and sketch the parabola from here. I'll just sketch this part of the shape. And I'll even shade the region, and let's picture what's going to happen when we put this problem in motion. So sometimes the trickiest part is sketching it in 3D. My first piece of advice is just sketch it in 2D. So I will resketch from 0 up to 8, that same left-hand side. Okay. Can you mirror that over the line of revolution? So do the same things, but it'll come down to 4, 0. So you get that kind of shape. Almost looks like a tent or a cone, or maybe a party hat when you spin it around the axis of revolution. A typical disc, right, would have come out from here, is going to turn into a circular disc, and these will be stacked up vertically throughout that shape. A better depiction of this is if I revolve. This is what I was getting at, what I was trying to draw. The computer does it way better. This is the shape we want to find the volume of, but it would be filled in, okay? Let's figure out the area of a typical disc. So here's a disc. Sometimes the tricky part is figuring out the radius of it, r. And because this is a vertically oriented problem, I want to think right function minus left function. And if at all possible, do the whole thing in terms of y. So bounding the region from the right in this 2D version is the line x equals 2. So I'll say 2 is the function that's on the right. Okay. Minus left function, here's this red little segment here. And that function had the equation y equals 2x squared. So that's fine, but I don't want to write 2x squared here. I'm trying to do this whole problem in terms of y's. So can you, off to the side or somewhere in the margin, solve this for x? Make it y over 2 equals x squared, and then regular x equals, let's just use the positive square root of y over 2. This is the expression we want. We want this right function, or I'm sorry, the left function, I should say, all in terms of y instead of x. So I'll use square root of y minus 2. Function, bounding the region from the left. All right, put that into area equals pi r squared. So pi times 2 minus, and I'll just write the whole thing as is, square root of y over 2 squared. And I say we join each other for this algebra. Let's actually get a head start on this problem and try to calculate the integral together. So we want volume, and we want to integrate from one y value to another. We mentioned 0 to 8 would be helpful. A pi r squared. So pi, I'm just recopying this expression, 2 minus the square root of y over 2 squared. Take this next part nice and slow so we don't make a calculation error. Get the pi out of your way. We can just slide it to the outside. Oh, and actually, I'm going to integrate in a second, so I'll leave the integral sign here. But I do want to FOIL this. If it helps, write it out twice and pause the video, see if you can figure out what that would be expanded. The rule is that it's the first term squared. When you square this, you'll get a 4 here, minus double the product. So double this times this is 2 times 2, 4 square root of y over 2. So a square root within it. And then plus, because a negative squared gives you a positive, this last term squared just gives you y over 2. That should do it for the last part, integrated with respect to y instead of x. Okay. Now, I think there's some rewriting we can do to make this a little bit simpler for ourselves. So we want to integrate from 0 to 8. I like the first and the last term, so 4 is fine. How about this term here? Let's get rid of the constant. So you have the constant 4 divided by the constant square root of 2. I just want to have that completely separate from the part of this expression that's a variable. And it's the square root of y, so let's call it y to the 1/2 power. Just trying to make it a little bit easier to integrate. So I think that's what makes this problem tougher. The last term's fine. We can just call it 1/2 y. Not much change needs to happen there. Okay, now it's time to carefully and slowly integrate. We leave the constant, and let's just put the rest in parentheses. The integral of 4, so 4 times the variable y. I'll leave the constant here, so it's 4 over square root of 2. We want to take y to 1 power higher than 1/2, so 3/2, which is fine as long as we also divide by 3/2, so times the reciprocal, which is 2/3. Okay. And lastly, the integral of 1/2 y would be 1/2 times another half, right? Y squared. So it'd be 1 over 4 y squared from 0 to 8. The calculator can really help you with the plug-in here. That middle term can be rewritten with an 8 on top. So we could write this as pi. We'll say 4y, that can stay, minus, how about 8 over 2 root 3? That can all go into the calculator, y to the 3/2, and then plus 1/4 y squared. Okay, I'm going to leave this to you. You're going to plug in 8. Oh, actually, get rid of the integral sign, right? Because we already did integrate. I don't know why that snuck in there. Plug in 8, subtract what you get when you plug in 0, check your answer with mine. As an exact value, you're going to get 16 pi over 3. Units cubed. As a rounded decimal, try 17 or 16.755. But I want to take a look at one of the ones that was further down the page. Can we look at number 6 together for the setup? Plus, it's good practice for us. We just tried a problem that had a vertical axis of revolution, so we did it all in terms of y. And this one is revolving about a horizontal line, y equals 4. So here's another example where we can go back to doing everything in terms of x. Let's give it a try. So first function is y equals 1/2 x to the third. Maybe just sketch a couple points on there that span this region. So 1/2 times 0 to the third gives you 0. 1/2 times 1 to the third just gives you a half if you want to sketch that there. And 1/2 times 2 to the third is half of 8, only takes you up to 4. So you get a curve, kind of parabola looking thing on this side. That'll go up like that. It'll actually extend this way, but it's not going to affect the problem much. Can you put the line y equals 4 on there? So let's do that. Y equals 4. We conveniently have the point that goes right through it. X equals 0 is going to be the y-axis. So we could actually shade at this point. The region bounded by these 3 curves is going to be this green shaded region. Now let's see where we're going to spin it. I could have had you spin it around an axis. This is saying, can you spin it around its axis of revolution? So can you put this in motion and spin it around the horizontal line, y equals 4? Because we're thinking horizontally, keep track of these x values. 0 to 2 will help us a couple steps down the road. Now we're going to try to sketch this in 3D. Let's put the line of revolution right on the picture. And then maybe, because this is so tricky, maybe for starters, I'll just sketch it in 2D. So we'll just sketch this part of it. You were kind of just curving from the origin up to the point 2, 4. Now, because we revolved it around this line, can you give me a mirror image above it? Spin it up above that line of revolution so that it goes up to 8. And you'll have that shape there. Doesn't look like much yet. I'm going to put a little oval or circle on the bottom to show this is like a kind of like a bowl on its side there. And then this is kind of hard to sketch too. A lot of this is tough, but you're going to say a typical disc is going to be circular shaped and it'll be oriented that way with a radius coming up from that spot. So let's see if we can sketch that disk out and see what in the world we would put as an expression for its area. Here's a better depiction of this shape. I'm going to revolve the region around the line, x equals, or y equals 4, we said, and this is what we're looking for, but not hollowed out. So back to the work here, back to the algebra, let's look at that disk. We want the radius here, I'll just label it r. In this case, last time we were talking about right function minus left function. Here in this shaded region, we have a top curve and a bottom curve. We want to get everything in terms of x and call the radius top, that whole distance minus bottom. So top function is y equals 4. I'll just put a 4 there. Bottom function is y equals this expression, that curve. So minus 1/2 x to the third, top minus bottom. And that'll go straight into area equals pi r squared. So pi times that squared. I think what we just got through is the toughest part of this question. Even the integration shouldn't be too bad here. We're going to find volume. We're working in terms of x's from 0 to 2 horizontally, this shape spans. Of this area expression that we're going to carefully FOIL in a second, 4 minus 1/2 x to the third squared. Like that. Leave the pi on the outside. Do some simplifying before you take an integral. Definitely carefully simplify the inside. So foiling it with itself, you get 16, which is 4 squared, minus double the product. So you've got 4 times 1/2 is 2, but if I double that, I'm back up to 4 x to the third for that middle term. And then plus this last term squared. So 1/2 squared, and x to the third squared gets me up to x to the 6th before I go into integrate. Everything in terms of x. Integral of 16, so 16x. Integral of minus 4x to the third, it'll be 4 over 4, so just x to the 4th. And then you had a 1/4, it's going to be joined by a 1/7. You'll also divide by 7 as you take x up to the 7th power. So 1 over 4 times 7, 1 over 28. Evaluated from 0 to 2. And this is where I left you to do the plug-in last time. Pi on the outside, plug in 2, subtract what you get when you plug in 0, which actually will be pretty quick to show here. So 16 times 2 minus 2 to the 4th plus 1/28 of 2 to the 7th. 2 to the 7th, minus 0, minus 0, minus 0. Once you're up to this point, you can check your exact answer with me. 144 pi over 7, and rounded decimal, 64.627. Do think this is a topic that takes time, and the more we practice, I hope the more that you see a rhythm with these problems too, but I look forward to the next time we meet.